Statistics Modeling of Finance, Chapter 4, Inferential Statistics, page 5. Another standard deviation example. Let me give you another example. It has nothing to do with real estate, but offers a good insight into how standard deviations can be utilized. Remember that statistics are tools for analyzing numbers. They can be applied in many different contexts. The Standard Intelligence Quotient (IQ) tests have been around for decades. They are structured and calibrated periodically so that the mean score is 100 and the standard deviation is 15. Does that ring a bell? Therefore, 68% of the population who take an IQ test score between 85 and 115. If you are of average intelligence, you would score 100. If you scored 115, you would supposedly be smarter than 84% of the population, or at least of those who took the test. Why 84%? Well, 50% have scored below 100, the mean. You scored at the level of one standard deviation above the mean. So you would add another 34% to the 50%. If you score 130, you are smarter than about 98% of the population. Look at the diagram 2 pages back. About 95% of the observations are within 2 standard deviations. Then there are about 2% in each of the tails at the extreme upper and lower ends. So you scored above 95% of the others plus the 2% in the lowest tail. The only ones who scored higher are the 2% in the highest tail at the right end of the distribution between 2 standard deviations. Of course, if you scored at 70, you would be in the lowest 2%, and 98% of those tested would have scored better than you. Do you know how they categorize someone being at the genius level? That would be if they scored 145 or higher on a standard IQ test. They would be beyond 4 standard deviations above the mean, and less than 4 out of 1,000 people score that high. Note, there are different versions of a standardized test for IQ, and most of them, such as the Wechsler Adult Intelligence Scale, the acronym is WAIS, and the Stanford Binet Intelligence Scales have 15 as the level for one standard deviation. However, a few, such as the Cattell Cultural Bear Intelligence Test, use 10 as the standard deviation. For purposes of quizzes in this course, however, we will always test based on the 15 standard deviation. End of page. Page 6, Z-table. Z-table. These 2 examples worked well with numbers representing 1, 2, or 3 standard deviations. But what if you want to know about a house that sells for $206,600 or someone who scores 94 on an IQ test? We can interpolate between those major demarcations by calculating a z-value and then employing a z-table. Z is the deviation of any variable, x, from the mean, measured in terms of standard deviations. The formula is z, which means the deviation from the mean, equals x, which means the variate, minus the little x with a line on top, which means the mean, divided by the standard deviation, s. let's stick with the first example because we know those numbers. The mean was $200,000 and the standard deviation was $10,000. Let's find the Z value for a sale price of $206,600. You put $206,600 minus $200,000, and whatever that equals minus $10,000, or divided by $10,000, equals Z. So 206,600 minus 200,000 equals 6,600, and then it says divided by $10,000. Z equals 0.66. Now let's take that calculated value of Z, 0.66, and look at a Z table on the next page. End of page.